In this video, we are going to look at how you would write ionic formula. There are 2 steps to doing this correctly. The first one is using the valency rules to get the chemical formula correct. And the second step is remembering to add in the charges. Remembering that the charge is equal to the valency of the element, and that the charge for metals, you're going to get a positive charge, and for non-metal elements you will get a negative charge. Let's work through some of these examples together. So let's start with a pretty simple one, sodium chloride here. Again, the first thing I'm going to do is we are going to write down the steps to work out the valency. Symbol, valency, swap, divide and formula. Sodium symbol is Na. Chlorine, the symbol is Cl. The valency for sodium is 1 and the valency for chlorine is 1. You swap them, can't divide them, so we write Na. Now here's where you have to write your charges in. Sodium is a metal, so it's going to have a positive charge. It has a valency of 1, so it's going to have a charge of 1 plus. Chlorine is a non-metal, so it's going to have a negative charge, has a valency of 1, so its charge is going to be 1 negative. Now we wouldn't usually put the 1s in when we write this, so we would write this as Na plus Cl minus. Let's move on and look at our second example, magnesium bromide. So again, write out the steps for the valency rules. I'm starting with the symbol. Magnesium is a symbol Mg. Bromine has a symbol Br. Magnesium is in group 2, so it has 2 unpaired out of electrons, meaning its valency will be 2. Bromine's group 7, so it has 1 unpaired out of electron, so its valency will be 1. Swap them over. We cannot divide them. Now this is where you need to remember to put in your ionic charges. So we only have 1 magnesium, so we don't need to put a number down the bottom. However, we do need to put our charge up the top. Magnesium's a metal, so it's going to have a positive charge. It has a valency of 2, so it's going to have a 2 positive charge. Bromine is a non-metal ion, so it's going to have a negative charge, and it has a valency of 1. So we can write it like that. And there are 2 bromines. So we can put that in brackets to say that we've got our 2 bromines there. And let's work through some more. So here we've got some more complicated examples that have our complex or group ions in them. And remember, you will find these in your data booklet. Calcium has the symbol Ca. Carbonate is a group ion. If you go to page 8 of your data booklet, you'll find that that is CO3 and it is 2 minus. Remembering that charge is valency, we can take that 2 minus here and put it down as our valency for carbonate ion. Calcium is in group 2, so it is going to have a valency of 2. We swap these valencies over. We can divide them this time, so we can do 2 divided by 2 is 1 and 2 divided by 2 is 1. And then we can write our formula. Now, when you write your formula, your charge does not change from this initial valency, even though you have divided down. Okay, so your charge stays the same. So we're going to have Ca 2 plus, and we've got 1 of them, and we've only got 1 carbonate ion, so we can write that CO3 2 minus, and that's our final answer. And let's just consolidate that by looking at example 4. Potassium symbol is K. Phosphate, again at your data booklet, is PO4 3 negative. The valency for potassium is 1. The valency for phosphate ion is 3. Swap them over. Cannot divide. It's going to be a K plus ion, and there are 3 of them. And we only have one phosphate ion, so we can write that like this. Moving on to look at silver 2 nitrate. So here we've got our complex ions and we're introducing our Roman numerals. So silver symbol is Ag. We've got a Roman numeral here, so we can put this down as a valency of 2. Nitrate is lifted from the data booklet and it has a valency of 1. If we swap these over, we can't divide them. So when we write our formula, we've got Ag, we've got our valency of 2 plus for our charge. We've only got one of them, we don't need to put that number down here. And this time we've got our nitrate ion and we've got 2 of them. So we do NO3 minus and 2 to show that we have 2 of everything that's in this bracket. And over to our lead sulfide. Now I've put this in just to remind you not to get caught out when you see sulfide versus sulfate or sulfite. Okay, sulfide is just sulfur. Okay, this is not a complex ion. So lead symbol is Pb, its valency is 2. Sulfur is in group 6, so it has a valency of 2. We can swap these, we can divide them to 1 and 1. And then when we write our formula, we have Pb 2 plus S2 negative. And moving on to our final examples here. You may want to pause the video at this point and try to work through these ones on your own and then come back to mark them. Again, I'm just going to start off by writing down my points here at the side, just to keep me on task. Lithium symbol is Li. Hydroxide is a complex ion. You'll find that in your data book it's OH minus. Lithium's in group 1, it's a valency of 1. Hydroxide has a 1 negative charge, so it has a valency of 1. We swap those, we cannot divide them. So our formula is Li plus OH negative. And moving on to our very last example of this video, we have strontium chromate. Strontium symbol is Sr. Chromate is a group ion, it is in your data booklet, it is Cr O4 2 minus. Our 2 negative is our valency 2. Strontium is in group 2, so it has a valency of 2. We can cross those over. We can divide them down to 1 and 1. So our formula is Sr2 plus Cr O4 2 minus, because we only have one of each.